Hello everyone. Good morning, good afternoon, or good evening, depending on where you're joining from. My name is Darshini Jayaprakash, and I'm a senior application developer at RESTful. It's a real pleasure to be here at Conf42 JavaScript 2025 track. I'm really excited to speak about this topic: API integration with JavaScript scalable, secure, and a future-ready system. Over the last few years, API have become the backbone of modern software, connecting the applications, platforms, and users more seamlessly than ever. But as systems keep growing and getting more complex, making sure these APIs are integrated in a way that's scalable, secure, and ready for the future has become a real challenge. Today, I will be sharing some practical strategies for building a reliable API integrations using JavaScript approaches that can help your system handle scale, maintain security, and stay adaptable for what's coming next. The APIs driven digital transformation. That means APIs have come a long way from being just simple data connectors today. They serve as the backbone of modern digital ecosystem. In our JavaScript driven world, APIs orchestrate microservices, facilitate a real time data exchange, and integrate diverse cloud platforms effortlessly. In this session, I'll share a data-driven blueprint for building an enterprise-grade API system that's not only scalable and secure, but also agile enough to keep a pace with constantly evolving technology landscapes. In our today's journey, we'll start by looking at RESTful API architecture, understanding the core principles and why it remains the backbone of modern development. Then we'll compare API paradigms REST, SOAP, GraphQL, and even some hybrid approaches to understand each makes sense. From where we will dive into From there, we will dive into the middleware solutions, exploring how modern platforms simplify integration complexity and accelerates enterprise connectivity. Next, we'll cover the security framework, focusing on OAuth, API gateways, and how a layered defense help protect the critical data. We'll then walk through some production best practices and that ensures the reliability, performance, and a great developer experience once your APIs go live. And finally, we'll look ahead at the future trends, including event-driven architecture and AI-assisted testing, to see where the industry is headed next. So by the end of this session, you will have a complete end-to-end view of how to design, secure, and future-proof your API ecosystem. Why RESTful API dominates? Let's talk about why RESTful API continues to dominate the modern API landscape, even with the rise of newer technologies like GraphQL and gRPC. First and foremost, REST is simple. It uses standard HTTP protocol methods like get, put, post, and delete, which every developer is aware of it and understands. That simplicity makes it easier to build, test, and scale applications quickly. REST APIs are also stateless, which means each request contains all the information the server needs. This makes them highly scalable, perfect for cloud native and distributed systems. There is also a massive ecosystem behind REST because it's been around for so long. There are countless tools, frameworks, and libraries that support across every language and platform. Till now, we spoke about why REST API dominates. Now we'll see what are the architecture benefits of it, which is scalability, interoperability, flexibility, and performance. Let's compare the three API paradigms, which is REST, SOAP, GraphQL. To understand the strengths and trade-offs, let's start with the REST. It's resource-based, lightweight, and widely adapted. It mainly uses a JSON and for data exchange and works great for web and mobile applications. Its stateless design also makes it easy to scale. On the other hand, SOAP is more traditional protocol-based approach. It's heavier because it relies on XML and has a strict message structures. However, it's still used in the enterprise and in legacy systems where reliability and built-in security like web service security are crucial. Then we have a GraphQL, the newer query-based model. Unlike REST, you get fixed data from each endpoint. GraphQL lets clients specify exactly what data they need. No more, no less. That makes it very efficient for modern applications that handle complex or nested data structures. In short, REST is simple and scalable. So is a robust but heavy. And GraphQL is flexible and modern. The best choice really depends on your project's context and needs. When to choose and approaches. Now that we've compared REST, SOAP, and GraphQL, let's talk about when to choose each one in a real world scenarios. SOAP still matters, especially in industries where security really takes a key role. Reliability and compliance are non negotiable. Think about banking, healthcare, government systems. These environments rely on SOAP because it enforces strict standards like web service security and supports reliable messaging and formal contracts between the services. So, even though REST dominates most modern web APIs, SOAP continues to be the backbone for mission critical and regulated workflows that can't afford a failure or inconsistency. On the other hand, we have GraphQL's rise, particularly in a modern JavaScript world, front-end applications. GraphQL gives the clients fine-grained control over exactly what they really need, reducing the number of round trips to the server. That makes it ideal for mobile applications where performance and bandwidth efficiency are key. Instead of fetching too much or too little data, GraphQL allows you to get precisely what's required, which translates directly into a faster, more responsive user experience. So, to summarize, SOAP is still the choice for a strict enterprise grade transactions. REST fits the most general purpose APIs, and GraphQL shines when you need a flexible, efficient data fetching, especially in a modern web and mobile applications. Middleware platforms reducing integration complexity. How is it doing? As organizations build more and more APIs and connect more systems together, one of the biggest challenges they face is integration complexity. Traditionally, integrating multiple systems meant writing a lot of custom code, dealing with different data formats, maintaining fragile connections and between services. Middleware platforms have completely changed that landscape. These platforms have come with a visual tools and a pre-built connectors. For example, to say connectors to Salesforce, SAP, AWS, or databases, which can reduce integration time by nearly half. Instead of spending weeks, months coding point-to-point integrations, teams can now configure, map, and deploy connections through intuitive interfaces. And it's just not just about the speed that I'm talking about. These enterprise middleware platforms also provide elastic scalability to handle varying workloads and real-time monitoring to ensure reliability and performance. In other words, middleware has turned integration from a painful manual process into a strategic exercise focused on configuration and optimization rather than a raw development effort. Key middleware capabilities. Now let's look at some of the key capabilities that make a modern middleware platform so powerful. Firstly, a pre-built connectors. Platforms come with an extensive libraries of ready-to-use integrations. For example, connectors to Salesforce and SAP, AWS, or databases which I mentioned earlier. These eliminates repetitive coding and dramatically accelerates time to market because teams can focus on configurations rather than building the code from scratch. Next, elastic scalability. Middleware platforms automatically scale up or down based on the traffic or seasonal demand. So whether it's an end of year sales spike or an unexpected surge of traffic on API calls, the system maintenance consistent performance without a manual tuning. Then we have a real-time monitoring system. These tools provide a deep observability, tracking metrics, logs, and alerts across distributed systems. That means team can detect the issues way ahead and fix them before they impact the users. And finally, visual design tools. This is where the low-code revolution comes in. Middleware now allows developers and even a technical business users to design, test, and deploy integration workflows visually with a minimal coding. This tool bridges a gap between our technical and non-technical teams, making an integration a shared collaborative effort. Altogether, these capabilities turn middleware into a true integration engine, simplifying complexity while boosting speed, scalability, and reliability. Security that plays a non-negotiable foundation. Now let's talk about something that's absolutely non-negotiable in any API ecosystem. Too often, security is treated as afterthought. That means we all think that We can build in security later in time once the API is all completely designed and developed. But that's really wrong. Something that which really need to take it at the first priority than being at the end. But in reality, it has to be designed in every layer of your API architecture from day one. When we combine measures like OAuth for security authentication, robust API gateways for managing and filtering your traffic, and comprehensive lifecycle management to track every stage from deployment and deprecations, we can dramatically reduce endpoint vulnerabilities. These layers work together to protect sensitive data, ensure regulatory compliance, and maintain trust, especially in the industries like finance, healthcare, or government. Else, rest on without its scalability, performance, and innovation simply don't matter. Multi-layered security framework. Modern APIs rely on multi-layered security framework to stay safe. We use OAuth for secure token-based access, API gateways to handle the rate-limiting validations and threat detections, and lifecycle management to enforce versioning, deprecation, and continuous auditing. Together, these layers form a defensive depth strategy, protecting against evolving threats while keeping APIs usable for legitimate clients. Production best practices. When it comes to running an API in prod, what do we really need to do? Making an API a best followed approaches. These are the following best practices ensures reliability, security, and a great developer experience. First is standardizing the naming conventions. Consistent URL patterns, clear resource hierarchies, and predictable endpoints makes an API easier to understand and faster for new developers to onboard. Next, rigorous testing that plays a key role where we can catch the major defects beforehand. Automated integration tests, performance benchmarking, and security vulnerability scans catch issues before they reach production, reducing the downtime and the risk. Finally, a detailed documentation, interactive API explores multi-language code examples, and clear versioning logs help developers adopt your APIs quickly and reduce support overhead. In short, standardization, testing, and documentations are the pillars of producing production-ready APIs. They make your APIs reliable, secure, and easy to use and scale. Emerging trends, event-driven architecture. What do you mean by event-driven architecture? A key trend in modern JavaScript ecosystem is event-driven architectures. Unlike a traditional request response models, event-driven systems decouple services and use asynchronous messaging, enabling a real-time data flows, improved resilience, and dynamic scaling. How does it work? We all know there are ways where you can just publish it and subscribe it when of any of the event or any change on that state. So firstly, the event produces. Service emits the event whenever there is a change in the state. Second, message brokers. Tools like Kafka, Topic, RabbitMQ route these events to the right subscribers. Event consumers. Other services react independently to the events they care about without tight coupling. By adopting these patterns, system can respond in a real-time scale dynamically under load and isolate our failures, making an architecture more robust and flexible for modern applications. Now coming to the AI-assisted testing and the future innovations. The big wave in API development and in operations is AI-assisted testing, and it's already reshaping how we ensure a quality and a reliability. We are now seeing a machine learning models that automatically generate test cases, predict potential failure points, and optimize the coverage strategies. This means less manual testing effort, faster release cycles, and higher bug detection rates, especially in a complex multi-service integrations where human testing alone can't keep up. Looking ahead, we are moving towards even smarter systems. Imagine a self-healing APIs that automatically adapt to failures or intelligent rate limiting that adjust based on usage behavior rather than fixed thresholds. We also see an automated security patching and predictive performance optimization, where AI can identify potential bottlenecks before they impact users. In short, AI isn't just helping us test better. It's redefining how APIs evolve, recover, and optimize themselves in real time. Building a future-ready API systems. To wrap up my talk, let's look at what it takes to build a future-ready API system. First, scalability takes the first priority. Design for growth from day one. Use stateless architecture, elastic infrastructure, so your APIs can scale seamlessly as demand increases. Secondly, security by design. Like I said, security takes a key role. Make security an integral part of every stage of the API lifecycle. Implement multi-layer protections and proactive vulnerability management and stay ahead of threats. And finally, the future adapt. Stay competitive by embracing emerging patterns like event-driven architecture and AI-assisted tool testing. These innovations will shape how APIs evolve and interact in the years ahead. With these strategies, you're ready to design and operate APIs that are scalable, secure, and interoperable and resilient. Even as technology continues to change, I would like to conclude my talk with this statement. The APIs we build today are the connections that powers tomorrow's innovation. Let's design them not just to function, but to evolve, adapt, and inspire what comes next. Thank you for listening to me.